All right, in these notes, we're going to look at factoring trinomials using what's called the AC method. And this is the most well-known or most commonly used method that you'll use for factoring trinomials, especially in this class. And so this is going to be really important for the next several sections. So just a couple of things to recall here. When you multiply two binomials, you use the distributive property. And the end result is usually a trinomial. So let's take a look at this example here. So x plus 5 times x minus 3. Remember, you multiply using the distributive property, x squared minus 3x plus 5x minus 15. And then you can combine like terms here, leaving you with the trinomial x squared plus 2x minus 15. Okay, so remember how that works. We're going to be, in these notes, going backwards through that process, kind of figuring out what numbers will create this middle term, and then we can move backwards to the distributive property. Seems challenging. We have a good method. Don't worry, it's going to be okay. Now, vocab word, quadratic. So what we're doing is factoring quadratic expressions. And these are polynomials with a degree of 2, which means the highest exponent in the polynomial is 2. So they usually start with x squared is what we're looking for. And then we have standard form of a quadratic expression, which is ax squared plus bx plus c. So really just the x squared term comes first, and then the x term, and then the constant. So this is where a and b are coefficients, and c is a constant. So just a few things to keep in mind as we move forward, a few vocab terms to recall. All right, so here's the process. And whenever you have a big list of steps in math, it always seems more confusing than it is. So we're going to walk through it. So the first thing I would do is make a table or a chart, because you're going to be trying to find factors of numbers. And so in this example, x squared plus 12x plus 20, first you want to identify what a, b, and c are. And in this case, a is 1, b is 12, and c is 20. And what we want to do is try to find a pair of numbers that multiply to AC and add to B. I've kind of got that in red here. That's what we're looking for. So the way I usually organize this is I make a little table, just a kind of a T-chart like this. I want two numbers that multiply to AC, A times C, which is 1 times 20, which is just 20, right? Multiply A times C. This is the product we're looking for, okay? And so I kind of want to write down factors of 20. That's 1 and 20, 2 and 10, 4 and 5. And now it says, be careful to look if B is positive or negative. And so our two numbers need to multiply to AC, which is 20. That's the factor, or the number we wrote here, the product. But we need them to add to B. So I'm looking for two numbers that multiply to 20 and add to 12. Now, if B were negative, that might throw a bit of a wrench in our plans. But what we can do here is just take a look. So 1 plus 20, that's 21. That's not it. 2 plus 10 is 12. That works. 4 plus 5 is 9. That doesn't work. So now I have my two numbers. 2 and 10 are two numbers that multiply to AC, which is 20, and add to B, which is 12. And so what I'm going to do is split and replace bx in the polynomial with those two factors. So we're going to split this middle term right here, that 12x. So x squared plus, we're splitting it into those two numbers. And it doesn't matter what order you write them in. So I'm going to put 2x plus 10x plus 20. Okay, so the process so far, identify a, b, and c, multiply a times c, so 1 times 20 is 20. Find two numbers that multiply to AC, which is 20, and add to B, which is 12. Those two numbers are 2 and 10. So we're going to split the middle term, kind of undo that combining like term step when you multiply. And now we can factor by grouping, so we have 4 terms. So the first group and the second group, take a GCF out of each one. We've done this before. First 2 terms, GCF is x, so x plus 2 is left over. Second 2 terms I can take out a 10, so x plus 2 left over there. And now I can write my final factored form. So x plus 2 is our twin expressions there. X plus 2 comes out, and then x plus 10 is what is left over. And that is the fully factored form for this expression. All right, so let's do a few more. So example A down here, we have x squared plus 4x plus 3. So what you want to do is multiply a times c, 1 times 3. That is 3, which is right here. And we want 2 numbers that multiply to 3 and add to 4. Well, the list of factors for 3 is pretty small. We only have 1 and 3, right? 1 times 3 is 3. And luckily, those 2 numbers do add to 4. 1 plus 3 is also 4. So again, we split that middle term. X squared plus 1x plus 3x plus 3. And in this step, it doesn't matter what order you put them. Okay, so because no matter what, you'll get the same 2 answers at the end. You'll just find different GCFs in the process, but you will get the same answers. So whichever order you write them in, that doesn't matter in this step. Now we factor by grouping. Take out an x, that's x plus 1 left over. The next set we can take out a 3. Again, x plus 1 is what's left. And then for our final answer here, x plus 1 is the first part of our answer, and then x plus 3. And there's our factored form. So again, we are just going backwards through that distributive property. We just have to figure out which 2 numbers to split the middle term into. Example B, identify A and C. I believe for these notes, all of our A values are 1. So this first step might seem redundant. 1 times 16, that is 16. They're all going to be like that for this section of notes. On the next one, we will add in different leading coefficients to make things slightly more challenging, but the process will be the same. So 2 numbers that multiply to 16, but add to negative 8. Okay, so when you have a product that's positive, but a sum that's negative, you know both of your numbers have to be negative. So negative 1 times negative 16, negative 2 times negative 8, negative 4 times negative 4. Right, because in order for the sum to be negative, at least one of the numbers needs to be negative. Otherwise, you would always get a positive sum. And if your product is positive, the only way to have any negatives involved is to have both numbers be negative, so you get a positive product. So both of our numbers need to be negative here. And in this list, only negative 4 and negative 4 add to negative 8. The others don't work out. So we're going to split that middle term. W squared minus 4w minus 4w plus 16. And now we can factor by grouping. So the first set, we can take a w out. That's w minus 4 left over. We should take out a negative number on the second one because the first term is negative. So we can take out a negative 4, leaving w minus 4. Now for this one, our 2 terms here are w minus 4. And then the leftovers are also w minus 4. All right, so this is just w minus 4 squared, or you can leave it like this as well. Okay, let's go on to the next one. X squared plus 11x plus 24. Again, our leading coefficient's 1. So we're multiplying to AC, which is 24, adding to 11. All right, so we have 1 and 24. That's not going to work, but I like to just start with that one. 2 and 12, 3 and 8, 4 and 6. That's all of our factors there for 24. 1 plus 24 does not equal 11. Can't be that one. 2 plus 12, that's 14, not 11. 8 plus 3, that's 11. That's going to work out. 4 and 6 is 10, so that doesn't work either. So we're going to split this middle term here. X squared plus 3x plus 8x plus 24. And if you notice, we haven't changed the value of this at all. 3x plus 8x does equal 11x. So we haven't changed this equation or this polynomial one bit. We just split the middle term into two numbers to get what we want. 3 plus 8 is 11. So all we've done is kind of reverse combining like terms, but we haven't changed the value of anything here. It's all the same weight. So we can take out some GCFs now. X times x plus 3. Then we can take out an 8, leaving us with x plus 3. That's good. So our two factors are x plus 3 giving me a little trouble here. X plus 3 and x plus 8. All right, last one we'll do here. M squared minus 13m minus 30. So we've got some negatives here. That's important to keep in mind. We got 1 times negative 30. So this actually should be a negative 30 here as well. And we're looking to add to negative 15. So because our product is negative, only one of our numbers needs to be negative, or can be negative. Otherwise, we'll get a positive. But because our sum is negative, we have negative 13. We know the bigger number needs to be negative. So positive 1 and negative 30. Positive 2 and negative 15. Positive 3, negative 10. Positive 5, negative 6. And the reason the bigger number needs to be negative here is because the sum is negative, and in order to have a sum with a positive and a negative, the bigger number needs to be negative. 1 plus negative 30 is negative 29. 2 plus negative 15, that's negative 13. That's what we want right there. The other ones don't work. Negative 7, negative 1. So now we can split this term, m squared plus 2m minus 15m minus 30. And now we can factor by grouping. So take out an m, there's m plus 2. And we can take out, looks like a negative 15, leaving us with m plus 2 as well. So our two factors here are m plus 2 and m minus 15. Now, throughout these notes, you may have noticed, and if you didn't notice, you're going to notice right now, that the numbers, give this a second here to figure itself out. Okay, the numbers that we found for our middle term to split, those two factors, for example, we found 1 and 3 on the first one. There's 1 and 3 in the answer. Negative 4 and negative 4 on the second one. There's negative 4 and negative 4 in the answer. 3 and 8, 3 and 8, 2 and negative 15, 2, negative 15. You might be thinking, why didn't we just skip all that work in the middle and go straight to the answer? And the answer to that question is you can do that. But this only works, that it's the exact same numbers. It only works when you have a leading coefficient of 1. And all of our problems on this section of notes had a leading coefficient of 1. They all started with 1x squared or 1w squared or 1m squared. And so it is good to notice that that happens, but it will not always work, because if you have any other leading coefficient, you have to do the grouping work in the middle. And so I like to teach it as grouping from the beginning, and then afterwards show that this shortcut exists. But again, it is only when you have a leading coefficient of 1. And so you'll see on the next section of notes that that is not always the case. So to be safe, multiply a and c together, find two numbers that multiply to ac and add to b, split that middle term, factor by grouping, and then you get your answer.